Button. Awesome. Hello, everyone. My name is Sheldon Callahan. I'm with the developer experience team at Atlassian. Maybe you've been at some of the talks in the track yesterday. We had a jam-packed group of sessions, so hopefully you guys aren't too exhausted. Um, this is the Atlassian platform for developers track. So we're talking about all the things on the platform. Yesterday we had a talk about Jira Server 8. And we talked a little bit about Lucene, so you maybe got a little preview of about what Lucene is about, but this talk is going to be a deep dive. So we have Kamil here from the Jira team, and he's going to go deep into it. There's some fun facts about him. I've been asking all the speakers to give me some of their fun facts. His fun fact was that at his first day at a new job at, what was it, Morgan Stanley, that he fell asleep during orientation and he must have been at Bash or something the night before. So, and he has some other stories he's going to share with you. Welcome him to the stage. Without any further ado, Kamil.
Hi everyone. Yeah, Sheldon asked me to tell this story myself. So when I was back at school, there was a meeting of the whole year of my class, and we were on a stage like that. I was sitting on a chair, and I was swinging a little, and at some point, one of the legs went out of the stage. So I flipped backwards onto my teacher, shouting. Well, I'm not going to cite what I shouted, and you can imagine what people were laughing and clapping. So that was my funny story. I'm going to keep this chair away from the stage, just in case. So welcome to this presentation about Lucene. Lucene upgrade, it's coming in Jira 0. And it's mostly for developers. I think, how many of you are app developers? Cool, that's great. But if you're not an app developer, there will be some high-level concepts as well. So don't run away yet. So we'll start, as promised, with a quick recap what Lucene is. Every time you do search in Jira, you type project text equals something. It's the Lucene engine, which is responsible for bringing the issues to your search, and it's also responsible for example, agile boards. So every time there is a query which returns issues, it's the Lucene which delivers those issues in quick time. And the way it works is something called inverted index. So you first scan all the documents. In our case, these are the issues. And you look what words are in each document, each issue, and you put them in a table. So for example, the table on the left would be the index. And then when you search, for example, you search for the word stop, you can immediately see that you can find that in document 0, but you cannot find that in document 1. So when you're searching, you just look into the table, you find the term or the word, and you know which documents match your search. And building the table on the left is called indexing. In our today's presentation, we have a hero. It's Ed. He's a Jira app developer like you. And there's also Ed's favorite plant, his Git tree. And wherever you see this plant, that means the API I'm talking about is not set in stone. It's under development. It might change until Jira 8.0 is released publicly. But I'm showing the current state of things. So Ed read our blog post, and he knows that Lucene 7 is coming in Jira 8.0. And he's wondering, why so? Why are we updating? So there are many improvements to the Lucene project. The Apache team has been working hard for 7 years, and they closed over 4,000 issues. They fixed bugs, they improved performance, they improved APIs. And also, we as a Jira Server team would like to improve the search system in the future, but we don't want to build on the old foundation. We wanted to first upgrade the technology stack, and then on a solid foundation, we can build our improvements. If it's so good, why haven't we upgraded for 7 years? First of all, it's a big effort. It's a big bank change. You cannot really stage it. And to make matters worse, it doesn't only impact us, it also impacts you. As you're here, you probably are interested how that impacts your app. And that's also the question that Ed is asking himself. Is my app affected? And the best way to check that is to use the milestone builds, also called EAPs. you can put a milestone version in your dependency. You can pull the latest Jira version, which is not fully baked yet, but it has all the changes we've got so far. And you can see what breaks in compile time. You can fix those, but that's not everything. You need to run your app and check in runtime, because some errors might occur only in runtime. So I would suggest you check all your functionality of Lucene in Jira 8.0, not just it compiles. Okay, let's ship it. So Ed has a couple of apps, and we'll be looking at the higher level ones and then going deeper and deeper. The first one is using only JQL. And there aren't many changes in JQL. The first change is that Lucene is now supporting regular expressions. So you put slashes, and in between you can put a regular expression for that search. And this is a new feature, but it also breaks everybody who was using slashes as a literal character, because now you need to put 2 backslashes to escape it. Not a big deal. The second one is fuzzy search. Fuzzy search is when you want to search for things that are close to your word, but not exact. For example, if I search for realize, and I wanted also to match the American spelling realize, I could use fuzzy search to match both. And in Jira 7 and Lucene 3, this used to be a number between 0 and 1, with the number higher, meaning the match should be more exact. But if you ask me what 0.0 means, I don't know. It's quite exact, but I cannot give you a definite answer. So now it's improved in Lucene 7, where you have a concrete number. It's 0, 1, or 2, meaning 0, 1, or 2 changes from the original word. So if I look for realize ~1, that gives me one change, which would match realize. The second app of Ed's uses search service and search provider APIs, and this is how we could compare them. The colors are not accidental. There is the bright side of Jira API, and there is the dark side of Lucene DMZ. But there are things that you cannot do in the bright side, so you have to go to the dark force. But the Lucene service, which is the API, is Lucene agnostic, and with the upgrade, it hasn't really changed. There are some cosmetic changes, renaming methods, but this would take 5 minutes to upgrade, and anybody using just API will not be affected by this upgrade. On the other hand, search provider is much closer to the Lucene. It references real Lucene classes, and that means that it was changed during the upgrade. And we also use that occasion to simplify its methods. We heavily restructured this class. And there's also one more distinction. In the past, both classes used to work on issues. So you would run a query, you would get a bunch of issues. Now there's this distinction that search service still works on issues, but search provider returns you raw Lucene documents. And if you need to have an issue, you need to use issue factory to create a document from that. But the advantage is you can use that to pull just some fields, not the whole issue. So if you look at the search provider class, there are 3 main methods. The main search, which returns you search results with those documents. And this is the main method for searching. There is the get hit count, which just returns you how many issues match your query. And there is also the more advanced search with a Lucene collector, which lets you traverse all documents that match, not just the first or second page that you would provide in the page filter in the first method, but you would get all the results. And these 3 methods more or less match what was there before, with one exemption. The collector used to have a method, so there used to be a method search and sort with a collector. Collector is this API that lets you consume Lucene documents one by one without loading everything into memory, so being memory efficient. But for sorting, on the other hand, you need to put everything in memory so that you can sort it relatively to each other. And these are 2 contradictory approaches, and it didn't make sense. And to make matters worse, with the internal Lucene changes, it was even less efficient to have this collector with search and sort. So if you are using that, you need to resort to the first method, which returns you results. Then you get a document with its ID. The ID is the same ID you would get in collector, and you can ask for an empty document, so it's more or less the same thing. You could notice that all three methods accept search query, and this is just an encapsulation of parameters that were loose before. So query, which tells you which issues you're interested in. Query permissions, which says, is it a user searching for something? Is it anonymous person? Or should you override security and match everything? And also the additional Lucene query, it's all packed into search query parameter. And the result is search results. In the past, it used to have a list of and now, because it's shared between search provider, it became generified, meaning that it can have a list of issues, but as well a list of documents. And it's transformable, so once you get search results of something, you can provide your function, and you can get search results of something else. And this is exactly what search service does, using the provider, getting search results of documents, and then comparing them to search results of issues. The next topic is paging API. We had plans to change the API, but we realized that the impact would be too high, both on us, Jira Core, Jira Software, and on vendors. So we decided to descope it. But because I had slides already prepared, I'm going to show them anyway. No, just kidding. The thing is, I would like to use this occasion to talk about paging API, good and bad practices, with what we have now. Quick recap, paging is for getting results in portions. So instead of getting everything at once, you ask for the first page, say first 1,000, and then when you're done processing these, you throw them away. You can process the second page, third, and fourth. But we also have this bad API, which says page filter unlimited. And this means I would like to have page results, but I want to have everything. And the problem with this is it can lead to out-of-memory errors. So we would like to eventually remove this API. But for now, the impact might be really high on some apps. So we decided to postpone this change. So how to use paging? You use page filter with 1,000 results. That's good. When you use 10,000, okay, it's still acceptable, but you're getting to the limit. But when you ask for everything, it's not really good, because if you look at this, there is this query, and it tells you which documents are matched. If you test it on a small instance with, say, 1,000 issues, it will be fine, it will work. If you move to a larger instance, but you have a good query, for example, specific project version, it would still return some reasonable results. But if you let the unaware user to type a query, and they type something like, give me everything, then you might really bring Jira instance down, because you're loading, say, 10 million issues into the memory all at once. So that's no go. And we would like to restrict the number of results in searches, but we haven't yet found the best alternative for that. So we postponed this change. But this is something you can do now. Have a look at the unlimited filter and change it to processing results in smaller portions. Slightly better approach is to use search provider and ask just for a specific field. So instead of asking for the whole issue, loading all the custom fields, description, title, you can, for example, just load issue author. And this is still bad because it can still load 10 million issue authors, but it would only load those authors, not the full documents. So it's slightly better. And if you do need to have all results, I mean process them, the best approach is to use a collector where you process one at a time, and there's no point in time where you have everything in memory at once. So you still can abuse collector, because when you're collecting the documents, you can just put them on a list, and the result is the same. It blows up, but at least you are warned. Mm, One thing to note about collector is that the results are not sorted. So if you need sorted results, you need to use one of these methods which return you a list, because the results from the collector are, the collector is called in the order which is internal to the Lucene index structure. So now Ed knows how to get data out of Lucene index, but he also has a use case where he wants to add more stuff to the index. For example, index his custom field. And to understand the changes here, we need to know what it means to index and to store a field. So indexing means building a structure that lets you find a document. For example, in here there are three indexed fields: text, speaker, and tags, with the distinction that they can be either analyzed or not analyzed. Analyzed means split into separate words. For example, text, you can see separate words, but the text is a longer field of text, and you can use any of these values, for example, the potential, to find that document. The speaker, on the other hand, is not analyzed, and that means that you need to provide the full value to find the document. And the second part is storing. So once you get to your document, you're interested what you can get in return, what you can get from this document, and these are the stored fields. In this example, text, speaker, and room are the stored fields. And have a look that you cannot use room value to find the document. It's stored, but it's not indexed. And conversely, tags are indexed but not stored, so you can use them to search, but once you get to the document, you cannot get their values. And how does it look in code? In the past, there used to be one constructor called field, and it would accept parameters. For example, not analyzed is now string field. So string is just a literal value that you index without any splitting. What used to be analyzed now is called text field, and what was not indexed and only stored now is called stored field. There's also this long point and other points like double point, float point, integer point that let you index numbers as numbers rather than as strings, as we did before in Jira. And this leads to efficient range queries in Lucene, and it is also multidimensional, so you can put more than one dimensional inside a single value. Okay, so now Ed updated his app. It compiles, and he called his colleague Eliza. He would like to show how well it works. They started a search, which was sorted, and bang, they got an exception. Unexpected dog values type none. The exception was definitely unexpected, and they're now wondering what dog values are, and Eliza was not impressed by this presentation. So to quickly explain what dog values are, the shortest definition is dog values is uninverted inverted index. And if that doesn't tell you much, let's have a look at the picture. On the right, I'm sorry, it's a bit small, you can see the index, which gives you values on the left and matching documents on the right. So for example, for value 2.7, you would get documents 2 and 3 that have this value. That's good for searching, but if you want to ask the opposite question, what is the value for document 4? If you want to ask what are the values for all? Oh, okay. What is the value for all documents? If you wanted to, for example, have a mean or average of these, this data structure does not help. What you need to do is scan all the values, look into the matching documents, and then build this table with all the values. And Ed says, okay, we already had that. It was called field cache. Yes, with the only problem that field cache is gone. Field cache used to be built in memory on demand, so you would consume CPU to traverse the index, build this structure. You would use RAM to hold it, and it was also a reason for Jira hiccups in the past. And the Apache team decided to ditch the field cache, and they replaced it with dog values. Dog values are built during indexing time. That means whenever you need them, you just read them from the disk. And that's much faster, and they are stored in a virtual address space, which means that the operating system will handle what's needed, what's not, and it will load only those parts of dog values that your application needs. And one thing that you might notice if you have a large index, because it's in this virtual address space in memory mapped file, that means that your app might show that it consumes, say, 150 gigabytes of memory, which is not real RAM, it's the virtual memory mapped to a disk. So you don't need to worry about those indications. And there are different types of dog values. The basic dog values, which let you get value for a given document. There are sorted dog values, which improve the speed of sorting results in Lucene. And they are also required for sorting results based on a field value since Lucene 6. And this is what Ed was missing in his app, where he asked for results sorted by some field, but he didn't have sorted dog values indexed. For Jira fields, we do index these dog values, but if you have your field and you would like to be able to sort on that field, then you need to index sorted dog values. And there's also sorted set dog values, which allow you to put more than one value for each document. Adding sorted dog values field is relatively simple. The way you added a string field, now you add another field, which is called sorted dog values field. You can use the same name as the string field. And querying is a bit more cumbersome, because for efficiency reasons, it is one-directional iterator. So you get this sorted dog values object from index reader, then you advance it to a given document, and then you pull the value. And you can advance it only in one direction. So once you get to document 3, you cannot go back to document 1. And this was done for efficiency inside Lucene. Okay, when you want to query, this API has changed as well. Do you write your own queries in your apps? Anybody? Okay, you'll have to update, but only a little. The Boolean query is now unmodifiable, so we need to use a builder to create it. Filter query used to be a special thing. It would have a special position in the search method. Now it became just another occurrence. So you have must queries, you have should queries, and now you have also filter queries. Boost used to be a parameter on a query, but now that the query is immutable, it became a wrapper. So you have boost query, and something from our side. We used to have all dates stored as dates. Sorry, all dates stored as strings. And now we are changing that to store dates as numbers. It will take less space in the index, and potentially it will be faster to search. And you can see this plant in the corner. We're still working on that, but I presume it's going to be available in Jira 8.0. Collectors. Anybody using collectors? Cool, brave people. So if you look at the index, the way we think about it, it is one index. But if you look inside, it's based off smaller segments, also called leaves. And each leaf is itself an index. So when you're collecting issues using a collector, you work directly on the leaves for efficiency. So when you're writing a collector, what you need, you extend the simple collector method, and you have two methods to implement. There is the doSetNextReader, which is called every time you move to the next leaf in your index, where you can get the reader for that leaf. And there's the collect method, which lets you load the document with the fields that you're interested in. You can load only selected fields, as we saw before, by providing a set of fields that you want. And something to note is that because now you're working in terms of leaves, this doc ID that you given in collect is local to a leaf. So if you wanted to collect all values and put them for later data retrieval, you would need to offset it by the doc base. And something to remember is that the doc IDs that you get in the collector are only valid in the context of one index reader. So the index reader is a snapshot of your index, and it never changes. So when you get these doc values, the doc IDs, you can query the same doc ID again and again, and you would get the same document. But as soon as you get next index reader, because a document was added, an issue was changed in Jira, this doc ID is worthless. It has no meaning at all because it can change in every time Lucene adds or deletes a document. And you can also use these sorted doc values within a collector. You would get the iterator each time you get to a new leaf, and you can advance to the value to the document ID that you're interested, and the advanced exact method returns you a boolean saying if a value was found for this field or not. Iteration over times. This is going even deeper, but just in case you needed that, we do that in Jira, so maybe you need that as well. To understand that, you need to understand the field, the index structure. It's a four-dimensional structure. So we iterate over fields with field enum. You iterate over terms with term enum. Once you get a term for a given field, you can iterate over documents that have this term. And then if positions are indexed, you can iterate over positions of that term in that document. In the past, there used to be a class term enum in Lucene, and that would have all the terms from all the fields. So the way you would use it was to advance it to a field that you were looking for, and then iterate. But each time you advanced, you would need to check whether you are still in the same field or you have already jumped to the next field. And this was not easy API to use, so they decided to rework it, and now the terms class only iterates within a given field. Once you get to the end of that field, that's the end of the iteration. One thing to notice is that terms are per leaf. So if you want to get all the terms from all the leaves of your index, you would need to use this multi-fields utility class, which is really taking all the leaves and trying to pretend there are one index. But more efficient is iterating over each leaf reader separately. The term docs class is also gone. Now it's replaced by posting enum. So now this is very deep, Marian Trench of Lucene. Let's go back to the surface and get some air. Ed has updated his app to Jira 8, but now he recalled that maybe some of his customers are still with Jira 7, for example, because Jira 8 is not out yet. So how can he support both? The easiest approach would be to have just separate branches in Git, and you merge your business logic, keeping the Lucene logic separate. And this is probably the easiest and best approach, but if you want to be more fancy, you could try having one code base with your business logic in one module, then your common interface for all your Lucene operations, and two implementations of that, one for Jira 7, one for Jira 8, and have your build system to build two different binaries. And if you want to go even further, and notice the icons with the ship and rockets, you could potentially build one binary that would detect in which Jira it's running, and based on that, it would load appropriate models. You could investigate doing that with Atlassian Pocket Knife dynamic modules, but this is not something that we tried, hence the plant. It's just ideas that we have, because in our case, for our plugins, we use the first approach. We just have separate branches. Not everybody is Lucene expert, probably hardly anybody is, so looking for help is a good thing. If you need help, the common platform is Atlassian developer community. Post your questions there. We and other developers will try to help answering those. And you can also use this platform to provide feedback. So if you think our new API is rubbish or you would like something else to be added, you can post it there. And as I said, asking for help is good. And I would like to just quickly share a story. When we started this project, we invited one of the Lucene committers, Uwe, to come and join us for a week in Atlassian. He came, he gave us training. He looked at Jira code, and he showed us how we could best utilize the Lucene 7 improvements in Jira. So maybe if you have very advanced usage of Lucene, that's something that you could consider. For us, it was very beneficial to hire a consultant and just get a quick kickoff. So recapping, we saw how to get ready with Jira 8.0 by using EAP. We saw differences in JQL, search service, search provider. We learned how to use collectors and how to iterate over the deep index. We know how to add fields to Lucene. We learned what not to do with paging and why you should not use unlimited filter. We know barely how to support Jira 7 and 8. We know where to look for help and how to provide feedback. And now I can see I was talking very fast because I still have 10 minutes. So if you have any questions, I'm happy to answer these. But before you start, I would like to encourage you to come to me after the session and talk about your experience with Lucene in your apps. I would like to collect feedback about the APIs, about how you write your apps, what do you use Lucene for. And please come, because if I come back to the office and my PM learns that I have no feedback collected, she will kill me, and you will not see me here again. So if you can come and talk to me, I would appreciate. Or we can schedule something for later today at a convenient time. So do we have any questions?
Yeah, so I was wondering, you mentioned that you get as a search result both Jira issues and documents. Can you elaborate on what those documents are? I mean, are those just extra documents you attach to an issue or something like that?
Yeah,
Is it attachments?
I'll try to find that slide with the new MacBook fancy thing. Somewhere here.
Because I was expecting I would just search for issues and only get issues, right?
So yeah, if you search service, you only get issues. So that's the API, that's the Jira API, and that's all you can get. The Lucene logic is hidden away from you. But if you go one level deeper, which is Lucene DMZ, which is not really API, and it's subject to change, you, instead of getting issues, you get documents. These documents are Lucene documents, internal Lucene structure that holds the data that is used to build Jira issues. So when you ask for an object of issue, it can come from two places. It could be either the database or the index. And the index has all these stored fields, which are then passed to the issue factory that we saw somewhere here at the bottom. So the issue factory gets a Lucene document and it produces an issue for you. If you use search service, this is hidden away and you just get the issue. But if you use search provider, you get the raw document, and you have to produce the issue yourself. And thing to note is this ID, because the document comes as a tuple with its internal ID of Lucene. Then you can use for some additional operations. For example, in issue nav, so when we are searching for issues in Jira with issues on the left and selected issue on the right, we do search for documents loading only issue key and issue ID, and we get 1,000 of these. And then for a given page that we are showing now, we can use those document IDs to load the full documents and load issues. But for the rest, we just keep issue IDs for reference.
Awesome. Any other questions? Okay, well, great. Well, thank you, everybody, for coming.
Cool. Thanks for coming. And remember to talk to me.
Please fill out the survey on the app and let us know how we're doing. That lets us know what kind of content that we'll have in the next year. So please fill that out. Thank you.